Hey folks, my name is Burke Holland and welcome to the Beginners Series to Serverless. In this video, I'd like to answer the question, what is serverless? This is a quote from, well, it's from me. And the point of this quote is that serverless has become more of a buzzword, and buzzwords tend to lose their meaning. It's more about the power of the word than what the word actually means. But serverless does have a meaning. What does it mean when we say that something is serverless? This is a definition that I like. Build applications without thinking about servers. Now, I don't mean thinking about actual server boxes, physical boxes. We never really did that. What I mean is thinking about all the things that you have to think about when you have an actual physical server box and not having to think about those things anymore. So here's some scenarios. The configuration of the runtime that you need. Do you need Java? Do you need .NET? Do you need Node? Are those things installed? Do you need a web framework to handle web requests like ASP.NET or Express? How much processor power does your application need? How much memory are you going to need? Can the application scale out to handle a lot of load? These are all the things that you have to think about when you're working with an actual server. Serverless architecture abstracts that away, so all you have to worry about is your code. Now, it helps to look at a concrete example. And the service that most people associate with serverless is something called Functions as a Service. Azure Functions is Azure's Function as a Service offering. With Azure Functions, you create single functions. These can be as simple as a single code file with a single method in it. And you can call that method in a myriad of different ways, like with a URL. You could do it with a timer, like on a schedule, or even when some other event happens somewhere else in Azure. And all of these different ways to execute your function are called triggers. Here's a simple example. Azure Functions projects are just folders, and inside are the functions themselves, and each function is a folder, in this case called Hello World. And the code that executes for that Hello World function is in the index.js file, which is inside of that folder. Now, this just demonstrates that a single file with a single method is all that's needed to make this work. You tell Azure Functions that this particular function should be triggered with an HTTP request, and Azure Functions turns this into an endpoint and gives you the URL to call. There's no web framework to worry about, there's no routing to worry about, there's no request handling to worry about. This is what we mean by not thinking about servers. And this is the essence of serverless. I'm only worried about the business logic of my application. I'm not thinking about how to expose it as a service so that I can call it. That part just works. Serverless has become quite popular in the last few years. Why is that? Well, there are some good reasons. The first and probably foremost reason is that it's cheap. There's no server to worry about, no physical machine to pay for, so there's no flat monthly fee. You only pay for what you use. You pay when your function is executed, and even then, it's just fractions of a cent. It's easy because there's simply less work required of you as a developer. Less setup, less configuration, you just put your code in and it kind of just works. It's practical. Serverless is good for all sorts of use cases and applications, from microservices to APIs, and it's also particularly well suited for one-off sorts of things, like, say, adding a process that runs at the end of every day that reads a database and sends an email with a summary of the sales for that day. In summary, serverless means that you don't have to think about servers when you're building applications. Serverless is popular because it's cheap, it makes life easier, and it's practical. And Azure Functions is Azure's Functions as a Service serverless offering. Principles of serverless. There are three principles that are important to understand in serverless applications: pay-as-you-go, event-driven, and stateless. Let's look at each one of these principles and why they are foundational to the technology. Pay-as-you-go. With serverless, you only pay for what you use. You can think of this kind of like a water faucet. You only pay for the water that you use. When the faucet is not on, you're not paying. You only pay when the faucet is turned on and there's water coming out of it. You only pay for serverless when you're actually using it. If you're not using it, you're not paying. With Azure Functions, you pay for two main things: an execution cost, which is a cost when your function is executed, and the amount of resources like RAM, CPU, etc. that is used while your function is running. The most important aspect of pay-as-you-go is that you never pay anything if your function is not going. If it's not running, you don't pay. There is no monthly charge. If you have a serverless project that never gets used, then you pay $0 for that. If it doesn't get used, you pay nothing. Serverless is event-driven. Actually, all computing is event-driven, but it's important to call it out in this context because serverless is really designed to let you easily respond to events that might otherwise be tedious to wire up. Each serverless function usually stands alone and does one thing. This is also known as microservices. These services are decoupled from one another and usually talk to each other with events. So for example, you may have one function that inserts a record into a table in a database, and a second function that listens for an event that is fired when that record is inserted and sends an email with some information from that record. These functions don't talk directly to each other, but they do work together. This is event-driven architecture. Serverless functions can respond to a large variety of event types that are built into the service. There are things like an HTTP request, a certain time of day, like a scheduled task, but more importantly, events that occur in other parts of your cloud environment, like, for instance, when a file gets uploaded to Azure storage. Serverless functions are stateless, and this means that if they're not running, they are what we call cold. And that means that the application is unloaded from memory if it hasn't been called after some amount of time. When the function is triggered, that code is pulled from storage and put back into memory and run. And because of this, all serverless functions are stateless, meaning they don't hold values in memory and they can be unloaded from memory at any given time. They are not long running for this same reason. There is a maximum execution time of between 5 and 10 minutes. After this window, the function will be automatically exited. So one exception to this is Azure's durable functions, which provides a mechanism for which you can create long-running serverless processes. To recap, the core principles of serverless are this: pay as you go. You only pay for what you use. Event-driven, standalone services that respond to system events. And lastly, stateless. Functions have a short life, and every time they are called, they are fresh. And Azure Functions can help with longer running processes that do need state with something called Azure Durable Functions. Use cases for serverless. In this video, we're going to talk about when it's a good idea to use serverless and when it's not such a good idea. Serverless is not always the right technology. Here are some general rules of thumb that you can apply to any operation to see if serverless would be a good fit. Serverless is good for any operation that experiences low or burstable traffic. What I mean by burstable is that the operation may be rarely called or it may be called a whole lot, but we don't know. So it's not called at all, and then it's called thousands of times within a few seconds. Then it goes back to being not called at all a few seconds later and stays that way for a long time. This is erratic and burstable traffic. The reason for this is cost. You only want to pay when your function is running, and if you are building a system with a lot of high traffic and a lot of load or predictable demand, serverless might not be the best option for you because you might actually end up paying more. In that case, you might want to look at traditional hosting systems like a virtual machine and or an actual platform as a service like Azure's application service, where you can prepay for a certain amount of compute. Serverless is a great option, though, for operations and processes that need to be triggered by other events somewhere else in your system. This is because with serverless, you are event-driven, and so you don't have to wire up all of these events that you need to listen to yourself. You just tell the function to fire whenever the event happens, and it sort of just works. Let's look at some concrete use cases or examples of where serverless really shines. Traditional APIs are a great option for serverless. These are endpoints that you create where a server acts as the API for your application. Often the server is just talking to a database and either retrieving data or making updates on behalf of the application. This is a particularly great option for single page applications. These are applications that are built with front-end JavaScript frameworks like Angular, Vue, or React. And in fact, it's such a great option that Azure Functions is built into the new Azure Static Web Apps offering, because it's just the easiest way to stand up an API for your single page application. Image processing is another good one. You may have an application that allows the user to upload a photo. You then need to resize that photo to make a thumbnail out of it. Instead of building all that into your application, what you do is write a serverless function that watches for that file to be uploaded and then takes it and transforms it into the scaled down thumbnail image. This is especially useful if you've already written the application that uploads the photo and you don't want to have to crack that code open and make a bunch of changes and then redeploy that application code. You could just write a serverless function that does all that for you without modifying the application whatsoever. Bots are also a particularly good use case for serverless because bots respond to human behavior, and human behavior is unpredictable. This can be bots like chatbots, bots with auto reply with a message like updating a customer on the status of an order via a text or a chat message, or service bots, bots that do things like pull in data or more information when you paste a link into Slack or Microsoft Teams. Human behavior is by definition unpredictable and erratic. You don't know for certain how many people are going to sign up to receive those order updates. You don't know how many are going to try to talk to your bot to get the FAQs answered. You don't know whether a customer will opt out of updates. Serverless is great for these scenarios because you don't know how much of these things will be used, and you don't want to be charged when they're not being used. In summary, you should use serverless when you have low or burstable traffic. You should also use serverless when you need to respond to events that are happening somewhere else in your system and you don't want to have to wire that stuff up yourself. Do not use serverless if you have a high amount of traffic and it's predictable. You can predict the traffic. In that case, look to traditional hosting solutions, which might actually give you more bang for your buck.
Hi everyone, my name is John, and in this video I'm going to show you how to set up your first Azure Functions project using Visual Studio Code. Let's start by creating our own folder. I'll click on Open Folder to do that. I'm going to choose this Play folder and say New Folder. I'm going to call it First Serverless API. Then we'll click Open. VS Code will reload itself at this point, and now we want to install the Azure Functions extension. We're going to do that by going to the extensions icon on the far left. Then we're going to type in Azure Functions. We'll choose Install on this first one up here. Now it may reload VS Code at this point. If it does, that's great. Let it do that. And it may also prompt you to install the Azure Core tools. So mine are already installed, so we're good here. Now next, you can see we have no files in this particular folder. It's because we haven't done anything yet. Now using the command palette, we hit F1. We can then choose to create a new Azure Functions project. So let's do that. We're going to choose the folder we just created, First Serverless API. My language I'm going to use is going to be JavaScript because that's my choice here. And then we're going to create an HTTP trigger because what I want to do with this project is just make an HTTP endpoint. When somebody calls it with a GET request, it's going to automatically return a bunch of products. So the first step in that is to create an HTTP trigger. And we're going to name this products-get, just to be super explicit. And our authorization level for the trigger is going to be anonymous. We can set this at the function or an admin level too. We'll choose anonymous here. And we can see that it's finished creating the project already. And in addition to the files that are created, we see the function right in front of us. This is just a sample function that's going to run. It's going to process the request body's name to see if we got in the request body or in the request query name, basically a name of a person. It's going to say hello John, hello Sally. So let's go ahead and run this and make sure it works. Now from the command palette again, by hitting F1, we can open it up. We can type in or search for terminal, create new integrated terminal. We can do that right down here in VS Code, and then I can type in func start. That is the function core tools running for us to run the Azure Functions. And it sees that we have this products-get endpoint. So now I can hover over it, and it will tell me with a tooltip how to open it right in the browser, or I can go to the browser and type that myself. So I'm going to choose Option Click here for me. It opens it up right inside of Edge for me. Now we can see we did not pass it a query string. So it's telling us that it executed the function, but there was no name in the query string. Let's go ahead and type in a name. So I'm going to type in name of Obi-Wan. And now it says, hello, Obi-Wan. This HTTP trigger function executed successfully. Now if we go back to our function, we can see that it's actually showing us the output down here in the terminal as well. And that's all there is to creating your first function project and your first running Azure function. Hi everyone, my name is John. In this video, I'm going to walk you through the directory structure and files that get created in your first Azure Functions project. Let's start by walking through the files and folders that got created for our first function project. And to do this, we're going to use a tool called Code Tour. It's an extension for VS Code, and you'll see what it does right here. It's pretty cool. We'll start the Code Tour up, and it shows us a tour of the application. So in this case, the first folder we're looking at is the products get folder. It's where our first function was created. Inside of there is a function JSON file. This is the configuration file for the function. You'll recognize some settings such as the auth level of anonymous and the type, which is HTTP trigger. These are what we chose when we created the function. And here's how we can change them just by editing this file. Next up, let's take a look at the function logic. Here we can see the index.js file. This is the function itself. Here's the sample function that got created for us, where it's going to respond to a query string parameter of name and say hello to that name. The next file up is a sample data file, where we can put different sample data for our application. And then we're going to jump over to the VS Code folder. Inside of here, there's a file called launch.json. This is VS Code specific. That's why it's in the VS Code folder, and it helps us set up a debugging configuration for Azure Functions. So what does it do? It means you can then press F5 and you can step line by line and use breakpoints through the function app. Then we're going to go down and look at the func_ignore file. It's .func_ignore, and everything that's listed in this file that matches any of these patterns will not be published to Azure. Very similar to a gitignore file, which you can see here, files that won't go up to Git, such as the local settings JSON. We'll come right back to that. And then there's a host JSON file. This is a specific configuration of metadata. It's a global configuration that affects all functions in a function app, because you can have more than one function in this project. Then we've got local settings. Now, this is what stores application settings and things like connection strings that are only used locally by development tools. And thus, we have that inside the func_ignore, so we don't actually push that up to the functions. Our package.json file is what we use to list our npm scripts and any npm dependencies that we might have. And then, last but not least, the proxies.json. This file is where you can specify endpoints on our function, and they're implemented by another resource. So what's that mean? So these things can be used to split large API surfaces into multiple function apps, and really just present one API surface for you. So now we've walked through all the basic files and the folder structure of what you get from your first function. Hi everyone, my name is John, and in this video I'm going to show you how you can modify the functions in your Azure Functions application and change the configuration so you can modify the methods that get called with your HTTP requests. Now let's modify our products get function to get a list of products. To do that, let's go to the left-hand side. We're going to add a new file by right-clicking. We're going to call this file products.data.js, just like that. And then inside the product data file, it's going to get a list of products like strawberries and loaf of bread. And I've got a snippet to generate this quickly. It's just JSON data here, so we can get that data into our function. And at the bottom, you can see on line 31, I'm exporting the getProducts function, which just returns the products. So we're going to use this from our Azure function here, up inside of the index.js file. Let's highlight all the code in our logic of our function, and we'll delete that. And instead, we're going to replace it with this code here. Let's walk through what's happening. First, we're requiring that product data file. So we're going to go get that JavaScript module. And then inside of our function, when the HTTP get is called, we're going to go off and call the get products. And then we're going to return back a status code of 200 and a list of products. Now, let's make sure we've configured this function the right way. To do that, remember configuration is in the function JSON file. Now we only want to use it for HTTP GET. We don't want it to be triggered on a post. So I'm going to delete the method for post and just save the file right here. And I also don't want to have to call API/products-get. I just want it to be API/products when a get is called. So to do that, instead of renaming folders and stuff, we're going to add another parameter down here, another configuration. This is going to be the route, and I can tell it whatever I want the route to be. In this case, it's going to be products. This means that, just to kind of put it down here, whenever somebody calls API/products with an HTTP GET, this function is going to be called. That's what that configuration means. All right, so now that we've configured it, let's run it. We're going to open the command palette with F1, and then we're going to go down and create a new integrated terminal. Once that's open, we're going to run func start to start our Azure Functions. Once it's running, we'll see the URL at the bottom. I'm going to hover over that link, and I'm going to follow the link by hitting Option click. And here in the browser, you can see we've got our list of products for our strawberries, sliced bread, and our apples. So we've configured the project and configured the function to run to get our list of products. Hi everyone, my name is John, and in this video, I'm going to show you how you can debug your Azure Functions application with Visual Studio Code. Sometimes it's helpful to be able to debug your application. So to do that, with Azure Functions, we're going to explore how we can configure debugging. Inside the VS Code folder, we have a launch JSON file. This is a file that got created for us when we created the function application. And here we can see that it's going to run func start right on line 9, and it's going to attach the debugger for us. So great, that's configured out of the box. Now we're going to go inside of products get, and let's say we wanted to inspect what's happening when we get those products. So in the index.js function, it's our logic, over in the gutter, I'm going to click right there on line 5, right where the red dot is. And that's going to stop the debugger there. So now we've got our breakpoint ready, and we have our debugging configuration. The next step is to run the debugger. And there's two key ways to do this. One is we can hit the F5 key, and it'll automatically crank up. That's the easiest. But let me show you a second way. Over here on the left in the activity bar, we can see the run and debug. We'll click on that. Now I'll stretch this out. You can see that we've got this configuration up top for attaching to node functions. You may remember inside of our launch JSON, there's a shortcut to it with this little gear. That was the name of our debugging configuration on line 5. So then we can click on this green button up top here. Once we do that, you're going to see the debug bar up top appear, and then you'll see func start is cranking up. And then when it's ready, we're going to see the URL down here in green. Now, when I click on this, we're going to open up the browser, but it automatically went from the browser back to our code. Why? Because we have a breakpoint right here in line 5. So what can we do with that? Well, out of the box, we see up top, we've got the debugging bar where we can run these different commands. So we can continue, we can step over, step into, we can also disconnect. Or we can go over here on the left and we can see that we've got our variables set up. So we can see we've got products, which is undefined at this point. That makes sense because the products are right there. Now, if I move my cursor around, which I can do over in this file, I can still edit things as I want. And if I hover over products, you can see there's nothing happening. Now, if I step over, now the products over on the left has an array of 3 objects. So here is my array of 3. And then if I close down the watch, we can see that we've got an object, and there's our fresh organic strawberries right there. We can also see we can set up watches if we want to. We've got a call stack, and we've got scripts that are loaded, as well as breakpoints, which we can either edit or delete, or just disable by unchecking the box right there, and then it'll turn gray. And when I'm done, I can just click on the continue button up here, and therefore go back to Edge, and we can see that the function's running. Now when you're done with the debugger, you can disconnect up here, and just to clean up the resources, the terminal's telling you you can close it with any key, or you can hit the trash can icon over here on the right-hand side. And then you're ready for another debugging session when it's time. Hi everyone, my name is John. And in this video, I'm going to show you how you can enhance your Azure Functions applications by installing and using node modules. There's a lot of great packages up on NPM. we're going to take advantage of one called datefns to format our dates because our product data here has dates in them. So to do that, we're going to go to the command palette. We'll open a new terminal and we'll type in npm install datefns. After it's done installing it here, we'll open up the package.json file. We can see we have a dependency now on datefns. Great. So now we can open up the product gets folder and open index.js. And we want to pull in a require statement here that will pull in that function package. So we can see now I'm going and getting datefns with require, and I'm saying I want to use the format function. And it's dimmed right now because it's not actually being used. So once I do that, we'll clear out the terminal at the bottom of the screen. I want to go down to line 6, and after I get the products, but before I return them with a status code of 200, I want to loop through those products and modify the dates by formatting them. So we're going to go ahead and do that here with a little for each statement. So for every product, we're going to go ahead and grab this product expiration, and then we're going to format it with a 4-digit year, 2-digit month, and a 2-digit day. Now we can run this project by either going and creating a new terminal, and then running func start, or we can hit F5 key. Let's go ahead and hit the F5 key this time. We have a debugging configuration out of the box. We can see the debugging tool at the top. And once our API is ready, we can come down to the bottom, hover over it, click on it, and we can now see our dates are now formatted with a 4-digit year, 2-digit month, and 2-digit day.
Hi, my name is Christian Wamba, and I'm a senior cloud advocate at Microsoft. In this video, I'm going to show you how to set up Azure in Visual Studio Code for deployment. The first thing you want to do is to sign into your Azure account through Visual Studio Code. And to do that, either you hit the F1 key or Command-Shift-P to open the command palette, and then search for Azure Sign In. Once you hit enter on Azure Sign In, you'll be redirected to Azure portal to give consent to Visual Studio Code. And to do that, just select the account you want to give access to, Visual Studio Code access to, and then you will be notified that you've been signed into Visual Studio Code, and you can close the browser tab. Now, if you head back to VS Code and click on the Azure icon, you should see that your subscriptions would be listed right here. Hi, my name is Christian Wamba, and I'm a senior cloud advocate at Microsoft. I'm super excited to show you how to deploy your Azure functions to Azure to the cloud using Visual Studio Code. If you've been following this series, there is a high chance that you have the repository that John has been working with, or rather the project that John has set up with you in the previous videos. But if you don't, just head to GitHub and clone this repository, which I will paste a link in the description for you. Just first of all, fork the repository. I already did that. I will just click on the link, and then I'm going to copy the repository, head back to Visual Studio Code, click on this Git tab, this source control tab, which would show us these options to either open a folder or clone a repository. In this case, I want to clone a repository, so I'll just click on the clone repository button, paste the URL we've copied, and hit enter. Now, Visual Studio Code will ask you which folder would you like to clone this repository into. So I'm just going to do that in my dev folder, create a new folder called John Papa, and then select this repository as a location where VS Code should clone the new John Papa's repo into. Once you've done this, Visual Studio Code would ask you, do you want to clone this repository, or do you want to open this newly cloned repository into a new VS Code window, or into this particular window we're working with? In this case, I'm just going to go with this particular window. And as you can see, we have jumper parts repository set up for us to deploy. But before we get ahead of ourselves and start trying to deploy, let's actually ensure that this is working locally first. To do so, we need to first of all install the dependencies. So run npm installed on this project directory and hit enter. Next, close the terminal and search for debug. Start debugging in the command palette. If you hit enter, this would start running our application. And after a few seconds, you should see that we have an endpoint to click on and test if our API is actually working. So if we click on this endpoint, we would get a list of all the products which you probably have seen in the previous videos while following along this series. Now this shows, at least this ensures that this repository is in good shape and it's working. So we can go ahead and start trying to deploy it to Azure. To deploy this function to Azure, head back to Visual Studio Code, close the terminal, stop the debugger, search for, open the command palette with Command Shift P or F1 and search for Azure Function, deploy. Choose the deploy to function app and hit enter. You'll be asked if you want to create a new function in Azure. In this case, that's what we want. If we had existing functions listed in our Azure account, existing Azure function project already deployed in Azure account, they'll be listed here as well. So in this case, I don't have any. So I just have only the option to create a new function app in Azure. So hit enter and pick a globally unique name for this function app. Globally unique basically means that you cannot choose another name that some other Azure client has chosen for an Azure function. So the best way to avoid this is to add numbers at the end of your Azure function name. So in this case, I'm just going to add a random number to it. Let's say 2343. Hit enter and then choose the runtime stack. In this case, we want it to be a Node 14 deployment. Once you do that, you'll be asked to choose the location for this deployment. You should choose something very close to you. In my case, I'm just going to choose a random location or just the first one, which is Central US. And then the deployment would start and you should see the notification pop up telling you that your deployment is in progress. Once the deployment is complete, click on the View Output button and you should see a link to the just deployed Azure function. If you click on that link, open it in your browser, you should see the same result we saw when we got testing on localhost, but this time we actually have a publicly available endpoint that you can share with your friends or anyone that you want to see your Azure Functions API. Hi, my name is Christian Wamba and I'm a senior cloud advocate at Microsoft. In this video, I'm going to show you how to make changes to an already deployed application or an already deployed serverless function and then redeploy those changes. I think a fun change to make to this project is to head into the function file and change the date format from year, month, day to day, month, year. But before we do that, let's actually run the function and see what this format looks like. So open the command palette and open the debugger. Now head to the browser and let's see. You can see that the date basically shows the format in year, month, and day. Now let's see if we can change this to day, month, year. If we head back to the Visual Studio Code and actually change this to DD, and then YY, and save, and head back to the browser and refresh, you should see that we have the date flipped. Instead of year, month, day, we now have day, month, year. Now let's see if we can deploy this, because from the previous video, our deployment is still showing year, month, day. So head back to Visual Studio Code, close the terminal, and run Command Shift, open the palette with Command Shift P, and search for the same command that we used to deploy the first time, which is the deploy to function app, and hit enter. Now you'll be asked to either choose to create a new function app in Azure or deploy an existing one. So in this case, we have an existing function we created previously. This is where we want to deploy the changes to. So if you hit enter, you'd be asked if you want to override the changes in this previous deployment, and yes, we want to do that. So if you click deploy, the deployment would start, and you would need to give it a few minutes to finish it. Once the redeployment is complete, you should see a message showing you that that's the case. So just click on view output to see all of your deployed endpoints, and then click on one of the endpoints, open it in the browser, and you should see that compared to the previous one, that the date format has changed to date, month, year. And that is how you deploy your Azure Functions to Azure. Now, if you want to learn more, or rather if you would rather take a guided learning path from like the basic level of serverless to all the advanced and exciting stuff, please check out the link in the description where I would add a link to a learning path that teaches you Azure Function from why you would need it in the first place to doing all the fun and advanced tricks using Azure Functions. Thank you.
Hi everyone, I'm Marie. I'm a software engineer on the Azure Functions team. In this video, I'm going to be explaining triggers and bindings. Let's start with some definitions. Triggers are what cause a function to run. Every serverless function needs a trigger. Because serverless functions are event-driven, they only run in response to an event. A trigger defines that event that causes the code to run. Some common examples of triggers are HTTP triggers, timer triggers, and queue triggers. Bindings offer a declarative way of connecting other resources to functions. Bindings connect to resources before and after a function executes. An input binding, which resolves before the function executes, brings in additional data for the function to work with. An output binding, which resolves after the function executes, pushes data from the function out to another resource. You don't need an input or an output binding in your function, but they can be useful. Let's see what this actually looks like with a code example. In this demo, I'll be using an HTTP trigger, a blob input binding, and a blob output binding. Here's my function app, which is a collection of functions that deploy and scale together. I use Azure Functions extension for VS Code, which gives me the ideal development environment. This is my single function called upload profile image. Function.json contains the definitions for my triggers and other bindings. Here I have an HTTP trigger, which I know from the type as well as the direction. My next binding is a HTTP output, which corresponds to the HTTP response. Lastly, I have a blob output binding. Each binding definition contains a type, direction, and name, where name is the property that's going to get passed in to my function. The other properties here are binding specific. In this case, connection refers to the name of the key in my local settings or app settings that has a reference to the connection string for a storage account. Let's press F5 to debug. My function will run when it's triggered by an HTTP request to this route here. The username I enter as part of the route will then be used here as part of the blob binding path. This is a binding expression. The code that runs will expect multi-part form data, and it will parse that into some sort of file name and file data. I'm going to convert that binary data into a binary string and then push that to profile image, which will end up under profiles username.json in my Azure storage account. Now let's run this URL, which I've already got set up in Postman. Zappy here is my username, so I'm going to expect in Azure Storage some file called zappy.json. When I refresh my Azure portal, I see that a folder was created. And now I see zappy.json. If I edit it, I should see that binary string as well. This shows what we can do with a HTTP trigger and a output blob binding. Now let's see what we can do with an input blob binding. For that, I'm going to create a new function, which is still going to be HTTP trigger. And this time I'm going to get profile image. I need to add a blob input binding, so I'm going to right click and then add binding. This is going to be an input binding, and it's going to be for Azure Blob Storage. This one is also going to be called image profile image. The path is going to be profiles/username, and I'm going to configure that route parameter in the same way that my first function did. So now this is configured to just have a plain old route, but I want a custom route with username as part of that route data. I'm going to copy this similar format. I'm going to add it to my function.json HTTP trigger binding definition and change it a little because it's not uploading anymore. Now in my function code, I need to do something about this profile image. Like I mentioned, an input binding brings data into the function. It is either passed in here as an argument, or it can be accessed on context.bindings with the same name, profile image in this case. I'm going to be using the data we get from the arguments. I'm going to modify this code so that instead of this text message, I'm going to be outputting the image from my blob account. So I'm going to be deleting most of this and changing what's put in the body. I know that the body is going to come from profile image.data because that was the format of my JSON object that I put in there. So body is going to be profile image.data, and I need to convert this data from a string representation of binary. So I'm going to do buffer.from profile data string type binary. Next, I also stored the type, which is the content type for the HTTP header. I'm going to add a headers object with content type set to profile image.type. I'm going to send and expect to see that image that I uploaded earlier as a response. And there it is. This is the profile image of our username, Zappy. I only showed you 2 types of triggers and bindings today, but there are so many more triggers and bindings that are supported out of the box. As you can see, there are many Azure and non-Azure services that integrate with Azure Functions through triggers and bindings. This means that there are a lot of use cases for serverless functions beyond serverless web APIs. Thank you so much for listening today, and I'll drop some follow-up links down below. Hi everyone, my name is Mari, and I'm an engineer on the Azure Functions team. In this video, I'm going to be talking about cron jobs and timers in serverless. A cron job is a Linux command that is used for scheduling tasks to be executed sometime in the future. Timer triggers are what we use in Azure Functions to create functions that run on a schedule. Cron jobs in Azure Functions are called timer-triggered functions. Conceptually, they're pretty much the same. Timer-triggered functions are great for automation. You can write functions that clean up resources, start and stop VMs on a schedule, create recurring notifications or resources, sync resources in off hours, implement a polling service, or help it with ETL pipelines. When you think about serverless, you probably think about near infinite autoscale and bursty, unpredictable load. So how does a regularly scheduled function fit into this picture? The first immediate benefit from serverless timer functions is that functions are billed per use. You only have to pay for the compute power while your function is executing. If you have a job that runs once a day, you won't have to pay for all that time that the function is waiting idly by. The second benefit of using Azure Functions for a scheduled job is that the programming model makes it really easy to use. You don't have to go and implement your own timer and deal with all the concerns of trying to implement something that will continue working on a schedule, even in the face of failures. Let's see what this actually looks like in code. In this demo, I'll be running a timer-triggered function to monitor the health of some API endpoint. Through this demo, I mainly want to show you what a timer-triggered function looks like so that you can write your own. A fundamental part of a timer-triggered function that every timer function has is this timer trigger type binding definition in function.json. This file was created using the Azure Functions VS Code extension when creating a new function. My function is scheduled to run according to this CRON expression. The expected CRON expression has 6 components corresponding to second, minute, hour, day, month, and day of week. I'll cover what the numbers, slashes, and asterisks mean later in this video, but the way to read this schedule is that it runs every 5 seconds. My function code that will run every 5 seconds just pings an endpoint, measures the time taken in that call, and then logs that time. It also logs if there are any 500 status codes. I'm going to run this with funcstart, although I could also run this by pressing F5. One thing that I did before having this actually run was to add in local.settings.json a connection string for Azure Web Job Storage. This connection string is a connection string to an Azure storage account, which is required to use timer-triggered functions. Now that my function is up and running, and it's struggling a bit because of all of the recording that is happening on my laptop, but you can see that it is running every 5 seconds, and it is measuring the time taken for that call to the endpoint. There's more I could do with this health checker function to use this data I'm now gathering. For example, I could build alerting on top of the logs from this function that get pushed to application insights. I'll leave that for another time though. One last thing that I want to show you is that serverless timer triggers execute as singletons, meaning that for a single timer, you will never have 2 overlapping executions. So if my timer here is configured to run every second, but my function code takes 5 seconds, I'll only see one function execution every 5 seconds. Here I have this code here that is sleeping for 5 seconds, And then in my function JSON, this star over 1 means that it's executing every single second. Now let's watch it run, and it's only executing every 5 seconds, even though my configuration says 1 second, because those previous executions are overlapping into the next one's time. This can be helpful if your executions are modifying the same external resource, for example. If you need to get around this behavior, though, you can with durable functions. Like I mentioned earlier in the demo, those 6 components for a CRON expression that will define the schedule have different types thrown in there, like numbers, slashes, and stars. I'm going to leave this chart out there, and I won't go through each of these in detail, but you can pause this video and read through it. There's also information and documentation available on the official Azure Functions docs for timer triggers. From this video, I hope that you took away that serverless timer-triggered functions are easy to use and they are powerful for any automation that you need to do. Thank you so much for watching, and check out some of the links below.
Hi everyone, my name is Simona Kotin and I'm a web developer here at Microsoft. And in this video, we're going to learn how to connect to a MongoDB database from our serverless API. And in order to do that, we first need to have a MongoDB database. And you can see here in my VS Code instance, in going into the Azure extensions, I have in my list of databases a beginner products MongoDB database, which is called serverless, that includes a product collection with a list of 2 documents. This is an Azure Cosmos DB database that uses a MongoDB model. And to connect to our database, the first thing that we need to do in our serverless function is run npm install MongoDB. And this will update our package.json file to include our dependency on the MongoDB Node.js driver. And then going into the index.js file, first thing that we want to do is actually import the MongoDB driver. So I'm going to type here const mongo client equals require MongoDB. And we no longer need to read our data from the static file that we used earlier. So I'm going to delete this import here of the product data file. And then I will replace the products object here to return an empty array for now. All right, so now we need to connect to our database. And to do that, we're going to define a connect function that's an asynchronous function. And here we want to initialize a client object that uses Mongo client to connect to our database. And we need to pass in a connection string. And to get that connection string, I'll go back into my Azure extension, the databases extension. And right here on the beginner products database, I can right click and you can see that I have the option of copying the connection string directly here from VS Code. So I'll click copy connection string, and we have 2 options. I can either paste in the connection string directly here in my code, but I would highly advise against that because our code will be committed to GitHub and we don't want to expose our keys right here in our code. So I'll go back into the file explorer and we can see here that we have a local.settings.json file. And this is a file where we can safely store our environment variables. So I'll add a new value here that's called db connection. And this is where I will paste in the connection string I've copied earlier. And in order to use it in our code, I'm going to have to use process.env.db_connection. And once we connect to our database, we want to return our client object, which we're going to use in our main method here in our function. So first, I want to initialize the client object and await for our connection to happen, to execute. And then I want to initialize or create a new object called database. And here I will use our client to select the serverless database. And just to test out that this is working correctly, I will console log connected to our database. And let me just go run this directly in VS Code. In the debug panel here, I will click the play button. And what this will do is it will kick off the Azure Functions runtime directly in my local machine, which will then allow me to run my application locally and debug my serverless functions very easily using VS Code. So let's go and first inspect what does our serverless API endpoint return now. You can see here it's an empty array, which makes sense because that's what we defined our list of products to be. We can also see the console log message connected to our database, so this is great. Next thing that we want to do here is use our database object here and select the product collection. And here we want to retrieve all products, so we won't have any filter function, and we want that to be an array. So once we restart our server, we'll be able to see the updated list of products. So going back into the browser, I'm now refreshing the web page. And we can see that our list is still the same, and that's because we want to actually await on the query results to be returned. So going back in our browser and refreshing the page here, and now we can see the two products that we have created or we have in our database. And let me just go back into the database itself and into the sliced bread document. And I've changed my mind. This is not the best loaf of fresh sliced wheat bread. So I'm gonna change that description and upload that data to Cosmos DB. And by refreshing the web page, we can now see that the data is being retrieved dynamically.
Hey there, my name is Alvaro, and in this video I'm going to show you how to upload images to Azure Blob Storage directly from your browser. What is the scenario that we are trying to solve? You just move to the cloud and you're using Blob Storage to scale your application requirements, and you need to start allowing your users to upload images directly to Azure Blob Storage. The problem is that you cannot share your account key with your users. That will create a huge security problem for your company. But luckily, there is a solution. Azure supports shared access signature keys that you can create to grant limited access to your users to either your containers or your blobs in Azure Blob Storage. So you don't need to share your key, your account key with them. So this way, we are not going to do it because we need to share the key. How do we solve it? To generate SAS keys, we are going to use an Azure function sitting in between our static web app and Blob Storage. And this Azure function is going to generate these keys that I just mentioned. Imagine that you are on a ski trip, you went skiing to the mountain, and you need to take the lift up the mountain. They are not going to give you the master key from the operator working at the ski lift. They're going to give you a one-time pass that you can use to go and take your ski trip. This is the same. The Azure function is going to generate that SAS key so your user can do the image upload. So let's see the code. Here in my web page, in my HTML, I will have that I will call the API credentials, which in this case is just the Azure functions. And this Azure function will return the SAS key and the URL. The Azure function is very simple. It's only calling this generate SAS token function where the SAS key is being created. How does that work? Let's say you want to say that your SAS keys can only last 2 hours. So the user has 2 hours to upload the image. In this case, we specify this as the expire for the SAS key. Also, we can provide permission. We can say this person can only upload to containers or to blobs, and you can decide in a fine-grained detail where they can put their images. And finally, we have the share key credential. This share key is a string that once the user does the request, it will be validated against your account key. So you don't share your account key, but we do share this share key credential that again is validated against your account key. So finally, back to the HTML, the file will call blob upload with your file, the file that you are trying to upload to Azure Blob Storage, and the URL and the SAS key that we received from API credentials. The blob upload function, the only thing that it's doing is generating this login URL that has as query parameters the container where you want to place their image, the name of this image, and this whole SAS key that we built. So the request is authenticated when it reaches Azure Blob Storage. So again, we do not share our account keys. We generate SAS keys, this single access key for the static web app to be able to upload to Blob Storage. If you want to learn more, here are 2 resources for you. The first one is the documentation about SAS keys directly on Azure Docs. And the second one is an article that I wrote detailing all this process so you can follow step by step, see the code, copy the code, and use it in your application. So happy coding and thanks for watching.
Hi everyone, my name is Johan and I'm a senior cloud developer advocate working at Microsoft. In this video, we'll see how you can create a Functions API in your Azure Static Web App. First, what's Azure Static Web Apps? It's a service that provides globally distributed static website hosting that's deployed from a single GitHub repository with a CI/CD pipeline using GitHub Actions. And among other nice features that it provides, you can easily add a serverless API to your website with functions. We start by creating a new app and deploy it to static web apps. For that, you'll need a GitHub and an Azure account. Both are free to create. Look at the links in the video description if you need to create one. Now, let's open this URL. So we can create a new repository from this template. So enter a repo name. For this example, I'll put my static web apps API, make it public, and then select create repository from template. When your new repository has been created, we'll clone it locally. We copy the repo URL here, then go back to the terminal. Type git clone, pass the URL, wait a bit, and now we can open this project in VS Code. So what we'll do first is install the Azure Static Web Apps extensions. And then we'll deploy this app. In the Extensions tab, search for Static Web Apps and install this extension. Now open the command palette with F1 and type Azure Signin. It will move you to the browser, prompt you to enter your credentials, and then, okay, we are logged in. Now going back to VS Code, if you look at this project, it's a bit unusual as it contains the same client web app, but built with different frameworks. You can see that there's Angular, Vue, React, and Svelte apps. I pick React for this example, but you can choose whatever that's more familiar to you. Now, open the command palette again with F1 and search for Create Static Web App. Type a name for your app. I'll put for mine My Static Web App API. Select Custom for the build preset, as our repo, as I explained before, has a bit of unusual structure. For the location of your code, you select manually enter location, then type in React App. If you choose to deploy a different version of the application with a different framework, just use whatever is suitable for you. For the API, choose Skip for now, as we'll see that later. And now we need to know the location of the build output. So build is fine for a React app, but it may be a bit different depending on the framework you've chosen. And finally, select a location near where you live. As for me, I'll choose West Europe. Then it will create the app, and once the app is created, you'll see this notification. Select Open Actions in GitHub, and it will take you to the GitHub workflow pages. The deployment will take a few minutes from now, so in the meantime, we'll take a look at what the GitHub's Actions workflow looks like that was created by the VS Code extensions. You can see directly in GitHub the logs for all the steps that are being executed. That may be really helpful if anything goes wrong at any point. After the workflow is finished, you can go back to VS Code and open the Azure tab. In the Static Web Apps sections, right-click on My SWA API and choose Browse Site. It will open the website in the browser, and now we have our static web app. But as you can see, it's stuck on this loading message. That's because there's no API yet. So now we'll focus on creating this API. First, let's pull the changes by clicking on the refresh icon in the status bar to bring in the workflow file that was created. Now it's time to create the missing API. Rename the folder API starter into API. This folder contains the function projects that will get deployed alongside your static web app. Now we need to create a new function. Open the command palette again with F1 and type in Azure Functions create functions. Choose HTTP trigger. For the function's name, type products-get and choose anonymous for the authorization level. Now, instead of this hello world boilerplate function that we have here, I'll just copy-paste this function code. What it does is get the list of products that could come from a database and return it. Otherwise, just return an error. For now, if we look inside the data, the product data is just a plain JavaScript object. You may change that later to plug in into a database, but that will do for this example. Now open the file functions.json. This file contains all our functions settings. So in there, as we want to implement a get function, we don't need that post here in the methods list. And we'll add a new parameter that's called root with the URL products. That's where we want to be able to call these functions. Now it's time to commit everything that we did and push our changes to GitHub. If we look at the GitHub workflow, you can see that by default it finds an API folder, and that's what will be used during the deployment. Now let's go back to our GitHub Action tab there, and you can see that because we pushed new code, a new deployment workflow has started. When the workflow is finished, let's take a look at our website again. Just a small trick, right from within the logs, you can scroll down here in the build sections, and you can find the URL for your website in case you just forgot it or if you don't have VS Code at hand. And there we have the list of products displayed. And that's it! You've now seen all the basics to create your own full-stack serverless web apps. You can find every link I've used in this video in the description below, and if you want to learn more about static web apps and API, take a look at the Learn tutorial that's linked there. See ya!